A, the whole thing is equal to 0. Okay. So I'm going to assume now, okay, I'm going to assume now that the moment is going to go anti-clockwise. Okay, I'm going to assume this one. Okay. So moment about A, I will have a moment going anti-clockwise, so MA, right? And then we will have minus 14 times 10 to the power 3 multiplied by a distance of 0.6 plus 0.3 is 0.9. Okay. And then the next one is by plus by 4 times 10 to the power 3 multiplied by a distance of 1.8. And the whole thing will be equal to 0. Now, Bx will not cause a moment because Bx is acting on the what? Bx is acting at along or at the what? Centroid. Okay, so you can see down here, right? It's exactly at the center. At the center means this is our geometric centroid. We are not going to see a moment. Okay, if it's not, we will see a moment. But for this case, we don't see a moment at all. Okay, so moment at about point A. Will be equal to 14 power 3 times 1.9. So it's equal to 12.6 times 10 to the power 3 minus 7.2. Okay, so this will have an outcome of 12.6 minus 7.2 is equal to 5.4 times 10 to the power 3 Newton. Okay, that is the moment of A. Okay, now the next thing that we will like to do is we can find what is AX. Okay, so we are going to do summation about forces in the X direction is equal to 0. So AX minus by BX, which is 9.6 times 10 to the power 3 is equal to 0. So we have AX is equal to 9.6 times 10 to the power 3 Newton. Okay. Yeah. So we have a load coming in at AX number. Now we have another, I do apologize, I forget this one. Okay. This is our AY. Okay. So AY, you just need to focus on member A, E, and B. Okay, you don't need, because now we are focusing on what is going on A, B, and E. That's why we only taking what is going on BY, BX at point E, at point A, and with the moments. Okay. We no need to consider DX or member BD because member BD, the load has been transmitted over here already. Okay, so we don't need to take that into consideration. You don't need to find what is going on AY. You don't need to consider what is going on down here. No need. Okay. So the next thing that we are going to do, dimension of forces in the Y direction is equal to 0, right? So from here we have what? Minus or AY minus 14 times 10 to the power 3 plus you have BY, which is 4 times 10 to the power 3. The whole thing is equal to 0. So therefore, AY is equal to 10 times 10 to the power 3 Newton. And it's positive, means this is valid. Okay. So from here, we found what is happening at point A. Okay, so point A, because it's built in, it has AY, AX, and it has a moment A. And this is focused on A. Okay. Now, This question, so this is the standard thing that we will do. Okay. Now this question is slightly not skewed, but it's slightly different. Okay. They want us to find what is going on. Okay. What is going on at A, B, and C. Okay. So A, B, and C over here, I'm going to draw a line, right? That indicate this is our point A. I'm going to draw the element. Point A. Then we have our point B. Okay, we have a point B. And then over here, we have our point C. And they specifically want to know at that location what is going on. They want to specify, hey, I just want to know at that location what is going on. Okay. So now I'm going to take the same diagram again. Okay. I'm going to take the same diagram again. Okay. Aye. Let's see what it works. And we're going to see, we're going to find the loads acting at point A, B, and C. And this time you'll see it slightly different. Okay. Now, point A, B, and C, okay, we know that we have a load down here that is our BY. Okay. So our BY, and we also know that we have a what? A BX. And our BY is equal to what? BY is equal to, let me find where is our BY. 4 times 10 to the power 3. And our BX is 9.6 and 10 to the power 3. Okay. So we want to find out what is going on A, B, and C. Okay. So to do that, right, we know that at A, B, and C, right, BX is still equal to 9.6 times 10 to the power 3 Newton. Okay. Now there is an AY. We are not going to consider AY yet because I'm not. So okay, I will also consider what is going on in the Y direction. Okay. Now in the Y direction, or forces in the Y direction, or I'm going to call this VY. So VY, for this case, I'm going to call positive that's coming down. It's equal to 14 times 10 to the power 3 minus by 4 times 10 to the power 3, which is equal to 10 times 10 to the power 3 Newton. Now, we are not going to do this, or we are not going to consider Vy yet. Okay, because we have not learned. I mean, some of you, if you remember, okay, not going to consider Vy because we have not gone into detail for what? For shear stress is equal to VQ over IT. I know you have seen this formula, but I've not taught you all yet. Okay, you probably seen it in 2P, but I've not taught you all yet. We are just going to focus on normal stresses for now. This is considering shear stress. So from here, right, we can also calculate the moment. Okay, moment acting on point A, B, and C. Now, the moment acting on point A, B, and C is not equal to moment at A. Sorry, moment at A should have, okay? It's not equal to moment at A. It's not, okay? It is equal to what? Okay, so it's equal to this, okay? So we have to take, okay, whatever that is only consider the right hand side of A, B, and C. Okay, so we are going to concentrate on the right hand side. Now, if we consider on the left hand side, the answer will be also the same. Okay, and I'll do that probably next Thursday. But I want you all to look if we consider the right hand side. Okay, so on the right hand side, what do we have? Okay, or maybe we will have time. So the moment at A, B, and C. Okay, so moment acting on A, B, and C, right, will be equal to what? Okay, so will be equal to 4. So I'm rather than 4. So anything that is anti-clockwise will be positive, right? So moment acting on Z, on A, B, and C, right, will be equal to 4 times 10 to the power, so it's positive 4 times 10 to the power 3, multiplied by 0.6 plus 0.9 now. So this is 1.5, right? 0.9 plus 0.6, okay? Then will be equal to minus 14 times 10 to the power 3, right? 14 times 10 to power, not, yeah, and multiply by 0.6. So this will be equal to 4 power 3 times by 1.5 minus 14 power 3 times by 0.6. Turn on your calculator first. Times by 1.5 minus 14 power 3 times by 0.6. So I have minus 2,400 Newton meter. Okay. So minus, what does it mean? So we know that positive is going direction. So this is in fact going in the opposite direction. So over here, this is our moment that is acting at point A, B, and C. Over here will be under compression. Over here will be under tensile. Now, let's now consider, right? Because we have the reaction at where? We have the reaction at A, right? And we also have AY. Okay, so we know, okay, so now I'm going to consider, okay, I'm going to consider the left hand side, okay, of point A, point B, and point C. Okay, when it's on the left hand side, I'm going to sketch this out. Okay, right, this is where our point A is. We know that we have a AY of what? 10 times 10 to the power 3, right? And we also know that we have a load coming in, right, at 9.6 times 10 to the power 3. And then we also have a moment, right? And the moment that we are taking on, okay, the moment is going down this way. Moment at point A is equal to what? Is equal to 5.4. 5.4 times 10 to the power 3. Okay, 5.4. Right? So if we use, so this is our element A, B, and C. So these are A, B, and C. And if we want to consider on the left hand side, the load has to be the same as we consider the right hand side. So let's look at this. Okay, so we know that by looking at here, Vy is equal to 10 times 10 to the power 3. We know that AX is equal to 9.6 times 10 to the power 3, right? 9.6 times 10 to the power 3. And just to highlight, what do we have earlier? So we also have Vy that is equal to 10, right? And we also have Vx. Oh, I did not write Vx. Yeah, Vx, which is 9.6. And we also have 9.6 over here, right? It's the same thing. But the moment is different. But the moment is actually the same. Okay, so now if we look at the moment, so we are going to declare that anything that is going in a what? That is going in the counterclockwise is positive, right? So now we will take that the moment will be equal to what? Moment at Z will be equal. So the 96 is going to be what? 9.6 is going to be positive, right? Because anti-clockwise, right? And then we are going to do 10 times 10 to the power 3. So minus 10 times 10 to the power 3 multiplied by a distance of 0.3, right? And not 9.6, 5.4. What am I doing? Hey, 5.4. Okay. So this will be equal to 5.4 minus 10 power 3 times 5.3 is equal to 2,400. And is going in the so this direction anti-clockwise is correct. Remember, anti-clockwise, this is the material, anti-clockwise is anti-clockwise outside material. So this is going to be compression. This is going to be what? Tensile. Answer is the same. Okay, so which one to use? Okay, do you consider just the right hand side on the left hand side? Either one you do is the same answer. The normal practice is you consider what's going on the right hand side. That's a normal practice, but this is a good way to check. Okay, this is a good way to check. Okay, that's all I have now. Have a fantastic weekend, and I'll see you guys again, or I'll be online or with you guys again on Thursday. Goodbye. Bye, Josh. Bye, Raymond.